Hello, everybody. This is day 3 still of LRVS, and we're thrilled to introduce actually one of our sponsors from Kluber, um, Alejandro Meza, who's the Senior Ability and Applications Engineer for Kluber. And he's going to be talking to us about taking oil analysis to higher levels. So thank you, Alejandro, for sharing with us today.
Thank you. Hello, everyone. And thank you for joining us. So let's talk about oil analysis and how can we take it to a higher level. We understand typically as oil analysis something like taking a sample of oil in a machine that is in operation, sending it periodically to the laboratory, get the results, and see the flags, if it's green, yellow, red, and making decisions upon that result. The fact is, this is a very useful, very valuable resource, the way it's used, but the purpose here with this presentation is expanding the vision. We can use oil analysis and lubricant inspections in different ways to maximize the detectability and the monitoring capabilities that we have in our facilities. So the first slide here is just a refreshment that probably we are familiar with, and is about the common oil analysis categories that we use to run our routine oil analysis. First of all, we monitor fluid properties, and fluid properties is all the intrinsic parameters, physical and chemical, that a lubricant has is related to its formula. So it could be viscosity, acid number, viscosity index, elemental analysis. We can use infrared to characterize the lubricant. We know that infrared, FTIR, is known as the fingerprint of every lubricant. And we use the fluid properties just to characterize, to identify the product. The next one is contaminants, and we understand that contaminant is whatever is not the pure lubricant that we install in the machine. It could be grease or oil. I'll be talking about oil analysis here, but let me say that many of these concepts are applicable also for grease analysis. Well, contaminant is whatever is not the lubricant pure. And we want to maximize the purity of the lubricant in service because contaminants may compromise the lubricant performance, and at the end may compromise the machine performance. There are some contaminants that we expect will happen naturally as a result of the machine operation. Let's say, for instance, soot production in an engine oil. Soot is a natural contaminant that is generated naturally, and we expect to see that. But there are some other contaminants we like not to have in there, like moisture, like solid particles, other lubricants, assembly oils, chemicals, and things like that. The third category is wear debris. We basically monitor here if the machine is running under normal wear. We know that we cannot eliminate wear totally. We want to have at least very low levels of wear. Under those conditions, the machine may have a very long life of many years. When wear is abnormal, we naturally know that the machine life will be shortened. We want to monitor how the machine is running to make sure that we'll have a long machine life. So by analyzing these three categories, we are monitoring the overall operation of the lubricant and machine. And we make sure that everything is running normally. And if it's not, we can take actions. And that's the basic routine oil analysis. But let's explore a little bit more about this. What are the purposes of lubricant analysis? We may consider different options. And I just mentioned some examples here in this slide. We have on the left-hand side the three categories that I mentioned: lubricant health or lubricant properties, the presence of contaminants, and machine wear. The first column says determine the right time to change or refresh the oil. We can use oil analysis to determine when is the right time to change the oil, and we can think on a large reservoir, large compressor, a turbine oil, and so on. where we take periodic analysis and we identify when is the right time to change it. And it may be based on the acid number, on the oxidation, on varnish presence, or other factors. But finally, we use the oil analysis to make a decision when the oil has to be changed. The second one, it says quality and clean new lube. And in this case, we may use oil analysis to characterize the product that we're receiving, to have a quality check of the product that is incoming to our facility. Let's imagine a lubricant in bulk or lubricant in drums. I can take a sample, check some basic parameters such as viscosity, acid number, to verify that is the product that I'm requesting. This may sound like redundant if we are receiving a product that has a quality certificate or a product that has the specifications. Why we should do this? We have experience of users that implemented this quality control, and they found sometimes discrepancies in the product that were discussed and resolved with the lubricant supplier. Another possible inspection for the incoming oil is the cleanliness. We can monitor particle counting and moisture to see if that lubricant needs to be filtered or dehydrated before we put it in the machine. The third one is optimize oil change intervals. It may sound like similar as the first one, but here the concept is slightly different. We may think as example, if we have a fleet of similar components that use the same oil, if we want to optimize the oil change interval in that fleet, we can select a few components, put them in the oil analysis program, and after time, using basic statistical analysis, we can estimate the optimum change interval. Once we define that, we implement that practice in the whole fleet. Next one, well, we identify contaminants, and that's one of the purposes. And if there is an undesirable contaminant, we should take actions. We're able to take actions before that contaminant may produce a problem in the oil or in the machine. Consequently, the contaminant identification may guide us to determine when we need to use additional filtration, or if we need to run dehydration in the lubricant, or if we need to change the lubricant if there is a harmful contaminant. So we can use this resource to identify if actions have to be taken to control those contaminants to not affect the lubricant life and machine operation. The next one refers to identifying incorrect operational conditions. If along the time we monitor the lubricant and suddenly we see some parameters changing, such as excessive oxidation, excessive soot, excessive wear debris, we identify that something is happening, something abnormal is happening in the machine operation, and it's important to take actions. So this is a good feedback for the maintenance team or the operations team to check if the machine is running under normal conditions. The next one is root cause analysis. We can run advanced oil analysis or advanced grease analysis whenever we had a failure and we want to research what was or what were the failure modes happening there. Normally, root cause analysis is more complex. It typically runs specific tests according to the information we want to get. And it requires many times a bigger sample, and we need to take the sediments or things like that to bring useful information to the laboratory to investigate what happened. Abnormal wear can be seen at the microscope. If we take a sample with abnormal wear, that sample can be observed at the microscope and seen the failure modes or the wear modes that happen in that machine. This root cause analysis may work together with root cause analysis on the component itself, like a bearing or gearbox and so on. And finally, we can run lubricant analysis just to verify that everything is okay. What if we identified some abnormal conditions? We probably filtered the oil, we probably changed the oil. Well, I want to verify that everything is okay to continue running. Also, I can take a sample of a lubricant that I just changed in a machine, not to identify wear, but just to validate that the lubricant is in good condition and everything looks good particularly if it's a critical equipment. So we can ask many questions to the lubricant, diverse questions, and it will be important to define clearly what we want to know from the lubricant, to set the tests that have to be run, and then get the response we are looking for. Another perspective here is the resources we have to monitor or to get the answers we are looking for. The first one is a routine oil analysis, is what we basically understand as a conventional oil analysis or used oil analysis. And it typically is supported by an external laboratory. In most cases, we take a sample, send it to a laboratory. Some companies may have an internal laboratory. This is more an exception. But the purpose is monitoring the oil health, the contaminants, the wear, as I mentioned. And it's possible to run exception tests to confirm results or to investigate additional information. This is what we basically understand as used oil analysis. But let's see, we can do more. There are field tests and field inspections. On the right-hand side, we see a sample. That sample was taken, it's a real sample taken from a gearbox that is using a synthetic oil. And we look at the color, it doesn't look like the synthetic, transparent, brilliant color that we know. And if I take that sample and inspect against light in a transparent, clean bottle, I may identify abnormal conditions, and I don't need to send that sample to the laboratory to take actions. I just know that it has water and probably another contaminant. I need to dehydrate that oil or change that and identify the water source. So field inspections are very simple, but sometimes very useful to take immediate actions. Additionally, there are some illustrations here of some instruments that we can purchase and get it and have in our facility to run certain tests to make immediate decisions. We may measure viscosity, moisture contamination, particle contamination, and some other parameters, hazard numbers. And if we have these resources with us in our facility, we can take a sample and get the results in a few minutes, and we are able to make a decision immediately. If we have a shutdown, for instance, we can take a decision if it's necessary to dehydrate, to change the oil, or etc., so on. All these resources, field tests and field inspections, are very valuable resource to have quick information and to make quick decisions. Another resource that is getting more popularity little by little, step by step, is on reservoirs or in circulation, where they monitor. When we can monitor the lubricant product, some sensors may detect specific parameters. We want moisture contamination, like counting, viscosity. Some other sensors measure the oil chemistry area. They are still not very precise. They cannot replace a good quality oil analysis, laboratory oil analysis. But they are useful to detect when something is not going normally. There are more precise and more sensitive sensors than others, but select the right sensor for application may report us immediately that something is not perfect, is not running normally. And while the sensor may not be able to tell exactly what is happening, it alerts us, send the information to a PLC, to our cell phone, computer, and we can take immediately a sample and run oil analysis. The fourth one is just a concept that is failure investigation, but the concept here is be aware that laboratories can run advanced oil analysis, advanced lubricant characterization when you need to go deeper onto some information, very specific information you may need. Sometimes the routine oil analysis lab may run special tests, or sometimes we may need to send them to specialized research laboratories. But this is a resource that is available, and we may be able to have the contact information, the laboratory information, whenever we need to use them for special oil analysis. So we have mentioned so far different resources, and let me add one more to this wider or broader perspective of lubricant analysis. That is, in this illustration, we see, we can say the lubricant life cycle in the facility or the fleet. Having common lubricant, that is receive a new lubricant, it goes through storage and handling, application and lubricant in service. Sometimes we are able to recondition the lubricant, filter the lubricant, dehydrate or sweeten the lubricant to continue the use. And well, in the left, right, and I mean in the right side, is something that we expect not to happen frequently, but is something that may happen when the lubricant or machine has an unexpected failure and end of life, and we can run analysis there. So looking at this lubricant life cycle, the incoming lubricant may be tested to check the quality, as I mentioned, or to monitor the cleanliness and determine the need of cleaning, dehydrating the lubricant. In the next stage, we can analyze the lubricant that has been in storage, that is in the warehouse, that is in the lube room. For example, if the lubricant has been there for a very long time, couple of years, 3 years, and we want to make sure the lubricant is still good to be used in machines. So we can run a good oil analysis on that lubricant to validate if it's suitable for usage. Also, cleanliness and dryness is another parameter that we invite to monitor at this stage. The next one is the lubricant in service, and here is exactly what we understand as a routine oil analysis. But the elements that we add here are field inspections and field kits or field laboratories, field portable laboratories. So with these three resources, routine oil analysis with external laboratory inspections and field test kits or mini labs, we can monitor the lube health, the contaminants, the machine wear, and maximize the detectability of abnormal parameters if they are there to take appropriate actions at the right time. Next one is if the lubricant has been reconditioned. Well, we just want to monitor that the lubricant is ready to continue in service and is good again. It has been dehydrated, it has been filtered, and is ready to be used. And finally, what I mentioned about failure investigations. Okay, what if we put all this information together? We can have a very broad understanding of all the resources we have through oil analysis, all the information that we can get through lubricant analysis. And as I mentioned, this is oriented to oil analysis, but a lot of these principles can be used also for grease analysis. We have, first of all, the categories of oil analysis, the goals that we are looking for oil analysis, that concept in the context of the lubricant life cycle, and the resources we have, routine oil analysis, inspections, field test kits, online monitoring, advanced oil analysis, advanced grease analysis. We have huge resources to maximize the lubricant, the detectability of normal and abnormal parameters happening in the lubricant. What we want to obtain with all of these resources? Well, certain to optimize the lubricant life, to optimize the lubricant performance. We want to maximize the machine life, maximize equipment reliability. Oil analysis and grease analysis is a great resource with this broader perspective to our reliability program. Okay, well, this is the end of my presentation. I thank you very much for your participation, and I wonder if you have questions.
Okay, so we have a few fans out there, right? So enhancing the vision, enjoy the presentation. Thank you, Sinead. And then Greg is coming in saying, How much does varnish potential testing play a role?
Well, varnish potential is very important in certain applications like turbine oils, compressor oils. And varnish potential is part of our routine oil analysis. And varnish potential helps us to predict potential future failures in the lubricant and in the machining consequently. Varnish potential should be part of our routine oil analysis in critical equipment, large machines like large circulation systems working at high temperatures, paper machines, turbine oils, critical compressors. Is a great resource for routine oil analysis in critical machines and large reservoirs where temperature may be a concern.
Excellent. How do you, in taking all this data together, right? So you've got the mechanical condition of the equipment, the condition of the fluid, contamination, and then all those criteria that you use, right? And how are you getting input from the field, right? So what actions have the reliability engineers done that may affect the results of the oil analysis when you see it? So how do you get that feedback from them?
Well, the first point we want to stress here is that lubricant analysis brings much more information than probably we thought in older times. And the reliability engineer should consider this as a very strong resource to monitor the overall machine operation. This resource should work together with other condition monitoring strategies. Vibration and oil analysis work fantastically together. Thermography also works well with oil analysis. So a reliability engineer should consider all the possibilities he has to monitor the machine health, the machine operation, machine reliability, and certainly there is a lot we can do in oil analysis, in grease analysis. Establishing a complete strategy like this needs certain steps. The user needs to be more familiar with the available tests, be more familiar with the lubricants they have in use, and probably receive some expert support on designing the monitoring plan that is suitable for their operation. What lubricants should be tested during reception, during storage, in operation, and what are the test slates that should be selected appropriate for every critical lubricant they have in the facility. So it requires some certain level of planning, but certainly it's something that offers great benefits for the machine reliability. There's another question here on about potential of sensors. Well, I see that this is something that is growing. I would say it is moving forward. There are better sensors now than probably just a few years ago. We are not there to say that using sensors will replace formal oil analysis. But certainly the sensors that we have available at this moment in the market may tell us a lot of information that is valuable. And suggestion, well, is these online sensors continue monitoring should be for really significant critical equipment we want to monitor perfectly, like in power generation plants, turbines, or large compressors in pumping stations and things like that. This is still ongoing. This is still ongoing, and certainly they are really valuable, but still do not replace a good quality oil analysis.
But and Alejandro, do you see an intersection of an integration with traditional laboratories and sensor technologies, right? Right now the sort of, in my view, separate sort of silos. What do you see in terms of any type of integration there?
Yeah. I expect to see that integration. I can just share that Kluber in the corporate office is working exactly in that integration. What we see through oil analysis and what we see through the technology of sensors and the condition monitoring, how can we work together and have a whole picture of the lubricant? there is an integration that really is happening with time. Everyone needs to talk. We need to talk and align the conversation and work together toward the goal of improving monitoring detection, monitoring capabilities and lubricant detection.
And I guess that goes beyond just sensors related to collecting oil condition, right? Even number of hours, operating hours, the environment in which the equipment is operating, not just the health of the equipment. Do you see an expanded data set coming in to help enhance that analysis of oil analysis?
You said the operational context of the machine, or a little bit of Internet of Things coming together, working together with oil analysis, something like that. Yes, absolutely. IoT is being developed in different fields in the industry. Lubricant analysis is part of that movement, and it is still an option that requires some resources. We may say if we want to have a really good capability in oil and gas at this moment, it's probably a little expensive, so it's suitable at the moment for critical equipment. But there are some companies out in the market there that are connecting very much all these capabilities. And as I mentioned, our corporate office is working a lot on this, how we can help customers to have a better monitoring strategy, combining IoT with other resources of oil analysis.
Excellent. You've got a shout out from Mike Ramsey. So very knowledgeable. Thanks for that.
Thank you.
So we have a few minutes left. Alejandro, any final thoughts, any conclusions you want to leave with us?
Well, we invite you participants to learn more about lubricant analysis, to be curious, to not believe that just lubricant is lubricant and the oil analysis is just managed by Flags. That's very basic. Go deeper on understanding tests, understanding lubricant properties. Discover what is good in high quality lubricants, in synthetic lubricants, in high performance lubricants, and combine that with your detection capabilities. We need to study, we need to learn, and there is a lot of to learn here in lubricant technologies and lubricant monitoring. The invitation is study, participate in conferences, read, go to advanced trainings and lubricant analysis, and get proficient in that area.
Excellent. And I would also invite you all to go to Kluber's sponsor page, interact with Kluber, find Alejandro's speaker profile in the app, interact with him, connect with him. Obviously, a huge source of knowledge. Alejandro, thank you so much for sharing your knowledge with us here today at LRVS.
Thank you. Thank you very much.
Thank you all.